Cool.
That
So
attitude.
it is 7 p.m. on a Monday at the Makerspace, so that means it's time to start drawing stuff in Fusion 360. So today we've got a request to do a little CNC project. So we're going to generate some tool paths as part of class today, so you guys can get a feel for when it comes to making your own project, what it'll take to generate some tool paths. So. All right, so we're gonna make a fairly simple sketch, and this is a thing that I have to make anyway. So I'm gonna, as usual, drag you along, kicking and screaming on the projects that I have to do in my own personal making. We're gonna start by creating a sketch here. So we need to create a sketch. So click on Create and then Create Sketch. I am going to draw on the top surface. So I often draw on the front, but in this case it'll just save us some steps later if we draw on the top, because we're going to end up CNCing this stuff, and the top is kind of like my Z up and down axis here, so I'll use my navigation cube so I know I'm looking right down at the top surface, or the bottom surface, I guess you could say, and I'll click on it here. So now let's create a circle. Actually, we're going to create a couple of circles. We're going to make a series of center diameter circles. And I'm going to start that center point right at the middle of my origin. Because it's all, like I said, it's always good to have something connected to your origin. We like to keep those sketches locked in position in space, as well as constrained by size. And speaking of size, this is going to be a 15-inch circle.
So how many millimeters is this?
15 times 2.54 would be 32 point, I don't know, 32 and a half?
I'm just kidding. It's all good.
Is that even close? Probably more like 34 and a half. Is somebody out there doing it?
38.1.
I was way off.
Cares.
Way off. 4 millimeters is not within tolerance. All right, so 15-inch circle, and just on a side note, if you wanted to, if you're drawing in millimeters, you can always just type in inches. So, and when you're drawing in inches, you can always just type in millimeters.
Now, will it switch everything to inches, or will
it just it does that conversion for you. So if I made this 15 millimeters, I just typed in millimeters, and now it tells me, 15 millimeters is 0.591 inches. But if I also double click on that measurement, it shows it to me in the measurement I typed in.
What number did you put?
15 millimeters.
No, I mean, what did you say for millimeters to?
To convert millimeters to inches, or inches to millimeters?
What was the number you gave for 15 inches in millimeters?
I gave 34 millimeters.
Close. 380.
Yeah. Centimeters, sorry, I should have said centimeters. Anyway, so 15 inches is what we're going with. And then we're going to make another circle. Actually, you know what? Let's do this. Yeah, let's make another circle. So we'll make another center diameter circle. And this one is going to be, let's put this at 12 for now. I don't actually know what these measurements are. I got a SVG file that was not the right size. So I'm gonna work on that on my own time. Now, I want to, in our circle here, create a series of holes on the around the outside here. A series of holes that are spaced a certain distance, that have a certain distance from the center, right? So in order to do that, I'm going to start by creating yet another circle. So I'm making a big ring. So this is like the inner diameter of my ring that I'm going to cut out, the outer diameter of the ring I'm going to cut out, and then it's got a series of mounting holes on it. So I'm going to make another circle. So I'll click on my center diameter circle tool one more time. Actually, this is the penultimate time we'll be using the center diameter circle tool. And I'll place the center of my circle concentric on the other circles. And right now, I'm going to make this halfway between those two circles, which would make it 13.5.
Yes.
13.5 inches. And I'm going to hit enter. Now, I can make my last circle that I need to make here. So from our create menu, I'm going to grab that circle tool one more time. I'm going to grab that center diameter circle tool. Now, I'd like this, it doesn't really matter where we put this circle on this ring here. I should be using our pointer here. We're going to put our circles spaced out evenly on this ring. It doesn't really matter where I start my first circle, because there's going to be an even number of them, and it's circular symmetry. But just for my own OCD nature, I'd like to have one of the circles be directly up above my center point as I'm drawing. And we can add that, we can make that happen by adding a constraint after the fact. So I'm going to start by making it purposefully in the wrong spot. So I'll click and I'll place the center of my circle right on that line. And I'm going to make it 0.5, half an inch. You know, just as we're talking about ways that you can type in measurements here, you can also do 1/2, and that'll get you a half of an inch when you're using the imperial metric system. Now, like I said, I'd like that circle to be directly over my center point. And that's for a couple reasons. A, it is, I don't know, it just looks like it was purposefully put there, right? Sometimes you will want to purposefully locate a circle right above something else. Also, right now, as it stands, our sketch is not fully constrained. And a fully constrained sketch is a happy sketch. It is a sketch that knows its place. It knows how the world works. Fully constrained sketch is bliss. And a fully constrained sketch is all black lines. And right now, this circle is not really fully constrained. It's got a size. It doesn't really have an exact position. So I can just click and drag on it and move it around all willy-nilly like. So in order to fully constrain that circle, I am going to choose to use the horizontal vertical constraint. So if I have nothing selected and I choose that horizontal vertical constraint there, right up, that's the very first option on my constraints menu. And I'm going to choose the center point of my circle, of my small circle, and I'm going to choose the center point of my 3 concentric circles, and then it will jump into position right up above it. And now you can see that that circle is also turned black, so that means it's a fully constrained sketch. And that ain't bad. All right. So now I'm going to do one last thing here before I leave this sketch, and then we'll kind of talk about 2 ways to make patterns. So I'm going to eventually extrude. Actually, I guess I don't really need to extrude this circle. I need to extrude everything except for this circle. But you can see my circle is being divided by our line, our circle that divides our 2 circles. So we don't, this circle here, this middle circle, this 13.5-inch circle is really only there to give me a position to put my hole on. So I don't really need it to be a solid line. There are other line types in Fusion 360. So this is a regular line, I guess I'm going to call that a regular line. I don't think it defines a line type for that. Just a solid line. But you can also make something what's called a construction line. So right now, a regular line, it divides these two things in half, so I can't select both of those things at once without holding down the shift key. I can take that line, and in the line type area of my sketch palette over here, I can select that construction button. Also, the X key on your keyboard does this. So if I hit the X key on my keyboard, or if you hit that little button, it changes our line type to a dashed line here. And a dashed line does not divide a surface into two parts. So we can have a line that's just kind of used for reference, or a sketch that's just used for reference, and we can place things on it without having to worry about it cutting up our sketch, and when we extrude something, we got to extrude 15 different parts.
If we want to, can we still use that line to extrude?
You cannot.
Okay.
Yeah, so
we'd
now
have to change it
you
back.
would not be able to extrude just one half of this.
Okay.
It would have to be changed back.
Oh,
yes.
I more mean, let's say we selected that. Let's see.
Oh, to extrude just the line.
Or, well, extrude the circle encompassed by just the line.
No, yeah, you cannot extrude the circle as just encompassed by the line.
You
Yeah.
gotta be behind. I do not know how you got to that. I'm sorry.
How we got to? Are you editing the sketch?
So that line is basically no longer
I got
capable of the face.
here.
There you go. So if you click on the line,
I'm gonna try to stick it
I think you gotta hit the escape key. You got a tool in your hand. You see that little
Oh,
icon?
okay, okay.
Says you have a tool in your hand. So now you can click on that line,
That's why.
and then you can click on the construction. There we go. Perfect. Cool. All right. So now I'm going to go ahead and say finish sketch. Now I said before that I want to make a pattern of this circle, and I'm going to show you two different ways to do that. So I guess I'm going to go ahead and say finish sketch. So this is my preferred method of making a pattern. So I'm going to come up and I'm going to, from my create menu, grab my extrude tool, and I'm going to extrude out. I'm going to extrude everything. So I'm going to extrude my hole and my ring. And I'm going to extrude it at a distance of 1/2 inch. And then I'm going to say OK. Now I'm going to do it one more time. So I'm going to spin my view around, so I'm looking at the underside of my object. So now my sketch is on the side of the ring that I'm looking at. So I'll be able to choose from the create menu again, the extrude option, and I'll be able to choose this time the hole. And then I'll be able to drag that through our object here. This is where it's really handy to think about future changes. I rarely draw things right the first time. I almost never draw something right the first time. And in fact, you know, there's a lot of unknowns that I might have about this project. And a lot of unknowns that I definitely do have about this project. Like what thickness the material is, that I will be using. So it could be that I'll have a 3/4 inch material that I'll actually need to cut this out of. So if I want to make as few changes later on, I can think about that keep that in the front of my mind. So I can choose to extrude this a distance of like 1.5 inches, or I can also say, instead of extruding it a distance, I can extrude it to what's called all. So I can extrude, instead of a distance here, I can change the extent type to all. And now, no matter what thickness that first extrude that I made did, no matter what thickness this piece is, the second extrusion will always take up the full width of that material. So I'll only have to change one thing as opposed to having to change two. And cut is indeed the operation that we want to be using here. So I'm going to keep that default operation. Because I'm extruding into an object, it has defaulted to cut over there. So, all right, and I'm going to click OK. Now we can make our pattern. So from our Create menu here, I'm going to go ahead and choose, and actually here, before we do that, let's talk about, let's do some housekeeping. So I've got a sketch here called Sketch 1. We're going to call it the ring. This body, I guess I'm going to call that the ring also. Anything is better than, we're not going to have any more sketches involved here, so just good habit to be in here. Another thing that you definitely can do, and especially if you're going to, other people are going to need to use this document and potentially make changes to this document, you can also name these icons down here. So that features in our feature timeline down here, because these are both extrudes, they both look identical. But they are not doing exactly the same thing. So if I right click on the features, any of the features in my feature timeline down here, we can choose to rename that feature, which is pretty cool. So I can choose this rename option, and now I can say that this is my hole extrusion, or my mounting hole extrusion. And now, if somebody else is coming to look at the document, and I've got a whole bunch of these down here, and they're not sure which extrusion did the thing that they're looking for, if they just mouse over, they can see it's labeled the mounting hole extrusion, which is again super handy. Again, if you got to share a document, or if you got 50 different extrudes down here, and you know you're going to want to find one later.
How did you get that again? Sorry.
So you right click on the feature that you want to rename,
Edit feature?
and then you say rename.
Oh, there it is. Okay.
Yeah,
Sorry.
so it's
I was being
fifth
duped.
from the top.
What did we name edit feature?
All right, so I was talking about patterns. So I like to make my circular patterns, and any pattern I can from in the 3D world. So I can make patterns on sketches. However, I really like this feature timeline. It's really handy. And so if there's two ways to do things, and one way gives me a feature down on my feature timeline, I will 9 times out of 10 pick the way that gives me another feature down here in my feature timeline. So that being said, if I click on Create and come down to Pattern, and then over to Circular Pattern, and now instead of an object type that is a body, I'm going to choose an object type of features. So features again are these things that are down here in our feature timeline. So if I choose the object type of feature, then anything that appears down here in my feature timeline, I can choose as the thing I want to make a pattern of. So again, this is where it comes in handy that I rename that. Like, oh, the mounting hole extrusion, that is what I want to make a pattern of. So I'm going to choose that as the object feature. And now I'm going to choose the axis to make that feature round. It is any one of those circles will do just fine. You could also pick the axis here in the middle, that blue axis, that would also work as the axis that we're revolving around. So that axis, or you can also pick any of these circles that revolve around, that move around that axis, or concentric around that axis.
How many do we need?
I am going to make, that is a fine question, I'm going to make 8. And then if I say okily dokily, there we go. Now we've got our ring here. So I did it this way because I know I'm going to have to change this, because the only real information I know right now is a 15-inch outer diameter. It's because I got a bad file. So I'm going to get more files, and then I'll be able to easily alter this. I could have, back in this sketch...
What is the object intended to be?
It's like a little cover for something at the museum I used to work at. So, again, I could have, if I would have wanted to... Why can't I right-click? There we go. I could have made my pattern here. I could have made my circular pattern when I was making the sketch. But I'm also not sure how many of that mounting holes actually need to be on this sketch. I've got a lot more questions than I have answers. So by choosing to, make it out here in my feature timeline, do it out here in so it's got an icon in my feature timeline. It's easy for me to double click on it and just say edit circular pattern, and then maybe he's like, oh yeah, there's 10 of them, dude. And then I put 10, and then we're good. I don't have to go back and edit the sketch.
I swear I told you it was 4.
Right, exactly, yeah. All right, cool. So now that we've got our thing that we want to manufacture, now we can leave the comfort of our design workspace up here. So this design window, actually, you know what? We should save this thing. So I'm going to go ahead and say File.
Good habits.
And I'm going to say Save. This is my ring mount cover thing. Again, I have so many questions. Okay. So, and I'm going to save it somewhere that makes sense for this project. Which is going to be in this folder for now.
Discovery World.
Discovery
Science
World.
Museum?
Yeah, I used to work there.
They have one here?
Yeah.
Oh.
Yeah. So, all right,
I didn't know
cool.
They were like a franchise.
They are not.
They're not?
Yeah, this is. There are probably lots of places called Discovery World. In a lot, or Discovery something. Discovery Planet. Discoverorium.
Discovery World.
All right. So now that we've got our thing made that we want to manufacture, we can leave the comfort of our design workspace, and we can head over to the manufacturer workspace. What for manufacturing stuff? All right. So now the first thing we have to do before we generate any tool paths is we have to first make a setup file. So a setup file is on the CNC machine that you'll be cutting this out, you will define where a spot on the bed where the tool is at its 0, 0, 0 position. So it's 0 in X, 0 in Y, and then 0 in Z. So when it's like right there on the bed, just perfectly touching it with like a sheet of paper barely sliding through it, that's your 0, 0, 0 point in the real world out there on the CNC machine. You need to define that point in your digital world as well. So a setup file is a thing that generates that digital position. So we're going to go ahead and click on the setup menu, and we're going to say, hey, we're going to make a new setup. Now we've got our first window open here. So this setup window has a number of different tabs here at the top. A lot of the things in the manufacturing workspace here will have tabs at the top of your windows, so you'll have to keep an eye on those tabs and make sure you step through all of them.
How did you open up that tab?
In the setup option here, you'll choose. You see?
Yeah.
Yeah, then you go to new setup. Yeah. All right, so the key points here, we are indeed doing a milling operation. So you can do other kinds of operations here. Honestly, I've only ever done CNC setups for a milling operation. I'm not sure what these will do, cutting or additive. I know you can make, Fusion 360 has like a 3D printing slicer built into it. So I've not used it, but maybe that's what this additive thing is to use the slicer inside of Fusion 360. But I only really ever do milling. Of course, you know, there's a turning operation here, but again, milling is where we want to be at. The orientation of our model is important here. So I chose to draw on the top because I knew that my z-axis would be pointed straight up. And this is the only way that you can mill something out here. So your tool will align with the z-axis. So our spinning drill bit or mill will align itself with that z-axis, and that is the only way we'll be able to cut out this circle. So if you did not start it like that, you can choose to specify to select the z-axis plane and then either the x-axis or the y-axis. So let's say you accidentally draw it on the wrong plane, or for whatever reason the item that you were actually making, you couldn't draw it on this axis for whatever reason. It's part of a larger assembly of products or of parts. So if I choose to select that z-axis and x-axis here, now I can specify as my z-axis, I can choose any face that points straight up. So that ring points straight up. And then as my x-axis, I can just pick the x-axis there. And now it would have reoriented. Again, it was facing the right way to begin with. This didn't need to happen. But just to show you how you can reorient your world or your object into the CNC world if you need to. I am going to just change it back to model orientation because it was right at the beginning. Now, in the real world, we will have a thing that is in our second tab here. The second tab is the stock tab. So the second tab, stock, refers to like the physical piece of material that you will be cutting this thing out of, right? We'll have a block of wood, or in this case, a chunk of plastic. And the default here for the mode in the stock here is to select is a relative size box. So what this is doing is it's saying, hey, your object, we know how big your object is. We're going to make it 0.04 inches bigger than what your object is. So right now this imaginary yellow block here is 15.04 inches by 15.04 inches because it's a 15-inch diameter. In the real world, I highly recommend that you choose a fixed size box. You will have an actual piece of material that you intend to cut this out of, and you should take that actual piece of material and you should measure it and know how big it is, and then you should use those dimensions here. So let's say I've got a scrap piece of material and it's 17 inches by 22 inches. And it's a ½ inch thick, which is perfect. So I would type in those real world dimensions into your stock here. It's easy to think like, oh yeah, fixed relative dimensions are fine. I just know that, so when I'm at the machine, it'll be fine, and I'll just remember all the things. And then you get to the machine and you forget a thing. It'll happen. It's never happened to any of us, I'm sure.
No, of course not.
Yeah, we never forget
None
a
of us
thing.
make mistakes.
So yeah, it's just, it's easy to type these numbers in. Just do it. All right. There's some other options here that we can kind of glance over. The position here, it's just going to center it inside of the stock exactly. And maybe you got a whole lot of stock. Maybe we got a piece that's 15 inches by 48 inches, right? Sorry, 17 inches by 48 inches. And it would be kind of silly to stick this right in the middle of our 48-inch piece. It would make much more sense to put it to one side. So we can choose, instead of centering it, we can offset it from one axis or another by like an inch, or a ½ of an inch if you're really trying to conserve some material here. So that way you can shove it all down to one side of your piece of stock material, or maybe you got one piece of stock and you're going to try to cut out several of these. So you can line your first one up there, and then you'll reline it up and you'll cut it out again. Making sense? Cool. All right, so the last thing here is the post process here. You don't actually need to worry about this tab. This is fairly new, this tab that got added to the setup. But you can name your program before we get there. Again, this is kind of it's weird to me that this is here. Eventually, this will be the name of the file that we open up on our CNC machine. So I'm just going to call it the ring, or like the 15-inch ring. And again, this comment, both of these sections will make more sense later on. In fact, maybe I'm going to skip them for now, because I don't think these make any sense at this point in the process. So I'm going to skip over this for now. This is a weird new thing that they've added. And I'm going to say OK. Oh, sorry. I'm actually going to not say OK. I'm going to right-click on it, and I'm going to say Edit, so I can come back here. Some very important steps here that we missed are we should choose the model, the body that we want to actually do the cutting on. We should choose that. So if I pick this, there's only one body there. So I make sure that I chose it, so it's highlighted blue, and maybe it was automatically already picked because there was only one body. The other thing that we need to do here is, though, I went through that whole big spiel about an origin and defining an origin in your digital world that you could match in your physical world. If you click on the little dot here at the middle, this is our origin. This is the origin right now of our digital world, this X, Y, and Z axis arrows here. If I've clicked off into no man's land, or if I just say escape, it won't let me move it at all. But if you click on that little point right in the middle of it, you'll notice that there are a whole bunch of points that have opened up on the corners and at the midpoints of your piece of stock. And now I can zoom in and I can choose one of those as my origin. This is a rule that I always use when picking my origins because somebody here told me that this is a good practice, so I just always follow this rule. Is I like to set up my origins at the top of my piece of stock, and so my x-axis and my y-axis are pointing away from my model. This is because now when you're actually on the CNC machine and you're moving your tool around, if you see a negative number, you're over your part. Negative, you're removing parts, objects from your part. So if you see a positive number, you're not going to be removing anything from your part if you're in a positive territory. But if you're in negative territory, then you're in an area where you're removing things from your part. I don't think that that's a practice by anybody other than this one guy who suggested it to me.
Is it Steve?
No, it was actually Bill.
Oh.
Yeah.
I think Steve was using that too, and he said that part of the reason is because you're more likely to just type in a number and forget.
Mm-hmm.
And so that you're like in a position where if it tries to move over it, it'll crunch and destroy itself.
Yes, exactly.
So in this, as opposed to a negative where you have to physically type the negative in, so you're less likely to accidentally destroy your bits.
That's also a good point. Yeah. Yeah, so again, the top surface, because it's really easy to locate your tool on the top surface. So you can find that point really easily. And the corner also for that reason, because it's easy to find a corner on your stock. All right, so now I'm going to say okay. Now we get to the fun part. We actually get to generate some tool paths. So I am going to start by boring out all of my holes. So I'm going to come into my 2D area. Honestly, 2D is a lot of stuff. So I think people go, oh yeah, all the cool stuff happens in this 3D area. But honestly, most of the stuff you do here is probably going to be in the 2D area here. So I would go here as a place to look first. As you explore this area, tool tips here are going to be really useful. So if you've never done a bore operation before, or you're not sure what a bore operation is, and if it's the one you should be using for the geometry that you've got, you can hover over your object here, and you can see the little tool tip here. So I actually didn't know that the bore operation could do positive pins like that. I've never
Positive
used.
and negative?
Well, it'll drill a hole, but apparently it'll also trace around a pin, which is interesting. So if you've cleared out the area around your pin using another method, you can use this bore operation to kind of clean up that pin. Probably get a really clean cut. So that's kind of interesting. I hadn't thought about doing that. But we're going to use it to drill our hole. I'm going to use the bore operation because I don't like drilling on a CNC machine. Really, it comes down to that. Has anybody ever drilled on a CNC machine?
I
just see a video.
Yeah, it's just
Steve do it.
it just gets really specific about the pitch angle on your specific drill and the speed you can go with it, and it's more things than I want to think about. Also, because I want to do more than one operation here, I'm going to bore, and then I'm going to also cut around the outsides of these things. I'm going to put these holes in, and then I'm going to cut around the outsides of this, and I don't want to have to switch my tool. So I'm going to be able to do the two things that I got to do with the same tool without having to switch or think about it. So I'm going to do this bore operation here. And now I'm going to do a little disclaimer here. This is the disclaimer we always do when we talk about CNC machining here in this class. Is this dialog box here is full of a bunch of very important numbers. It is full of a bunch of very important numbers that I'm totally not going to talk about at all. And the reason I'm not going to talk about these numbers at all is because this is all about feeds and speeds. It's about how fast the tool is moving, how fast the tool is rotating. And I can't talk about that because I don't know what material you are going to be using for your project when you actually come and use this knowledge. There are feed and speed calculators on the internet that you can type in how many flutes your mill has and what if you're using aluminum or steel or HDPE or wood, and what good cutting feed per tooth rates are and feed rates are for different materials. Some materials you want to go slower in because some materials you want to go faster in because they hotter they get, the harder they get. So going fast moves that heat along. Feeds and speeds again are super important, but the best way to figure out feeds and speeds for your project are figuring out feeds and speeds for your project and not just taking whatever information I type in here and using them for your project. Lots of qualified professionals hang out in the metal area, and I'm sure they can recommend websites for you. In fact, I can do so after class.
Want it spinning so fast that it burns your eye.
Right. Yeah, exactly. Yeah. All right, cool. So now that we're just completely glancing over that feed and speed area, we do have to pick a tool, however. So the tool here, you have to select something. And I am going to choose from my cutting tools edge. Where are all my tools? Where are my tools, bruh?
Turn library on.
Maybe I gotta. Why is my library turned off? Oh, there we go. I just had to click turn library on for whatever reason.
In my case, I clicked turn library on and it says no data.
Oh.
Cool.
Cool.
This is a database of tools that you
Click on
yourself
the-
have ever put in.
Click on the milling tools inch.
Milling
Right
tool.
bottom.
Oh, milling tool.
There you go. Now try to turn it on.
Oh,
There we go.
okay.
Yeah.
I was in
So,
cutting tools.
so this is another thing. So over on the right-hand side here, I think this is the best way to narrow down your options here. So I'm gonna find a flat. I'm just looking at flat end mills, and I'm looking at then on the other side I'm looking at milling tools inch. So they're milling tools that are based on inches. If you got metric milling tools, I support your choices. And I'm going to pick an 1/8 inch flat end mill. Because that will let me do my bores and then do the next operation after that. And then I'm just going to choose the select option. All right, so now that we've got our cutting tool selected, again, all these windows have tabs. So the next tab over here is our, I think this is the geometry tab. Does it? Yeah, it's the geometry tab. So now I will have to select the circular face selection. And the face that we want to choose, or the circular face that we want to choose, is the bottom of our hole. So it's not the ring. Oh, actually, you can just select just picks the circle for you. That's cool. So we can just select that inner face there. and it will just make a whole bunch of blue lines there. That is totally fine. And we are going to zoom in and zoom out and select each one of the faces of our holes as we go around here. Just one at a time, all the way around. And there we go. And then I'm going to go ahead and say OK. Now we've got an operation. Look, it says bore. These are things that you can also name. So these are it's the 8 holes. Actually, I think there are 10 of them, but you know.
Mine went weird.
Green?
Yeah, the whole thing turned green. Oh, then I select off. Let's see. Okay, never mind.
Cool. All right, so now let's cut out the inside of our circle here. So that inner diameter circle there. We can do that with a really common operation, the contour operation here. So if I choose the 2D and I'll choose contour, it is going to remember that 1/8" flat end mill that we picked the last time, and it's going to select that as our default here, which is indeed what we want to do. So we're going to use that same flat end mill to cut it out. It would also remember all the feeds and speeds. So it would remember that feed and speed that you typed into that you did your diligence on, and you typed in all those information bits based on the website that you found and people that you talked to who were smarter than me. You typed in all that information. It remembered it from me last time. So now we can pop over just to the geometry tab, and we can select the contour that we are going to cut out. And this one, we do want to specify the ring that is the bottom of our circle. So if we pick the ring at the top, it won't do any cutting. You have to tell it where the bottom is. Now, something that we will keep in mind here is that when our tool cuts out,
Harvey, or the base contour?
what's your question?
I said base contour. I'm sorry, I
You're good,
don't know
you're
if I
good.
click on the right thing. I think I click on this and that. Just exit
You could just click on the X button there.
this one.
Yeah, and then do that again.
Okay.
Yeah, so look at it a little bit
This
more
one?
three-dimensionally,
Oh.
so we can see which is your top and which is your bottom. There you go. So now I would pick that ring right there.
I'll do it
There
that
you go.
way.
There we go.
What would happen if you selected the face? Would it just bore out the entire face?
I'm
to
not
that point?
sure it would recognize that at all.
Seems to be able to select faces.
Yeah, it may not generate
Yeah,
any
because
tool
the
paths
default
for
is.
it though. So what will happen when our bit runs around, our mill runs around this and goes all the way to the bottom, is we'll have a circle here that's just loose and flopping around. And flopping little bits and parts in a mill, generally bad practice. You don't want flopping little pieces in your mill, because if it's loose and free, your mill could grab it and throw it at Tim when he's over there on his laptop minding his own business, and Tim is not expecting to have things thrown at him. So please don't. So what we're going to do to hold this piece in is use tabs. So again, here, great tool tips in Fusion 360 in general. If we hover over where it says tabs here, you can see what it's going to do, and it'll generate these it'll leave bits of material that kind of hold on to our part temporarily, and then we can cut those away afterwards. So if I click the checkbox by tabs, Now I can specify a size for those tabs. And I can specify an amount, a frequency of them. So tabs every inch is probably overkill here. I'm going to put them like every 6 inches. And that will be just fine. It'll put, a couple, 4 or 5 of these around the outside ring here, the inside ring. Just holding onto our part a little bit. And then later on, we'll just be able to clean those up with a trim router. All right, cool. Now, the last thing that we want to do here is, unlike in our bore operation, with contours and with most of the other operations that you'll want to choose, you'll definitely want to look at the 4th tab over here. This is the passes tab. I believe they call that passes. Yeah, they call it passes. So what this tab is all about here is how deep will your bit plunge into the material at once before it starts cutting things out. So right now, it's going to plunge in the full 1/2 inch depth and then cut out that full 1/2 inch depth. We'll actually want to cut it out in much smaller increments, probably 1/8 of an inch or less. What's that?
Wouldn't it be a really good place to break your bit?
Yes, exactly. Yeah, break your bit or worse. So we want to accomplish this by using multiple depths. So if we hover over, or if we go down to the multiple depths checkbox here, down here near the bottom, and I just check that little box. And now a general rule, again, it depends on your material and a lot of things, but a general rule is half of the width of your bit is a decent starting point for the depth that you can plunge with that at one go in a full cutting width path. So because I'm plunging into the middle of the material, I'm cutting the full width of that 1/8 inch bit. So we're going to do 0.0625. Honestly, in a lot of materials, you can be more aggressive than this. And with some end mills, you can be more aggressive with this, but life's too short to be in a hurry, man. So I'm going to change that maximum roughing to, again, half of that width there. And now that that's done, now I can say, okay. And it will generate some lines. So those are the lines that it's going to use to cut out that interior circle there. So we would be using that same operation to cut out the outside of our circle. But I'm going to skip that because we're coming up on 8 o'clock and I want to get to the last and most important thing here. So we would be using that same 2D contour operation for our outer circle here. But instead, we are going to pretend that we're done. And we're going to get ready to export a thing that our CNC machine here can read. So in the Actions menu here, there are 2 things that I want to point out. So A, we can choose that Simulate option. And what this Simulate option will do here is it will lay out our stock. And I can push play here if I wanted to, and it'll show me exactly how it's going to do each one of these things. It's going to go down and cut out our part. Down here is a little timeline here. This is the steps. This is the playhead as it's moving through. This being green is a good sign here. If you see bits of this timeline that turn red, it means that something has gone wrong in the simulation. So it could be that you the thickness of your material is too thick for your bit. The height of your bit might not be deep enough to go all the way down, and in order to get the depth, the machine head is running into your part, and it gives you those warnings as red lines down here. So because this is all green, this is good news. I can also.
Wait, sorry. Could you repeat some of the?
Yeah,
So I have a ton of red lines when it starts getting to our little circles.
You do have a ton of red lines?
Yeah.
Yeah.
It started apparently with the inner circle for mine. So,
Oh no,
but
you've got no red lines. Oh, down over there.
over there, yeah. Which is when it would be getting around to the itty bitties here.
Yeah.
See where it is for that. Oh, there's something about that red line. Oh my, it even found another one apparently.
I'm not sure what it's doing there.
There we go. Oh, it bumped something right there. Unless maybe that's its tabs? Maybe those are the tabs.
Yeah, maybe.
Consistently bumps right there. Oh, now it's given a big, there we go. Look at that red line. It just suddenly started generating.
Oh yeah, so your
all
bit
red.
is not long enough for whatever depth you want it to go down there. Yeah, but so we can look at that later. But we can also look at the statistics here, and in the statistics tab, it'll tell me how long it's going to take to cut this out. So this is 17 minutes of machining time at the speed and feed that is going at currently. So it's kind of just handy to know, like you can look at that. Sometimes you go, oh, 8 hours, cool. That's just a full day of me staring at the CNC machine, great. I'm gonna exit this simulation for now because the last thing that we want to do is we want to post-process. So post-process means make yourself some G-code. And look, G-code. Ooh, they call this human readable. G-code is apparently human readable to people who know how to read G-code. I mean, it is literally telling you an X position and a Y position, but it's just, you know, knowing exactly where that is in the machine is a whole other thing. All right, so now is where we get into the last bit here. So
So I click post process and it comes up. So actions, post process, right?
Yeah.
It comes up with this.
There you go.
Okay.
Yeah.
But
So
then if I click post, it just gives an error.
So you want to first you have to choose a post processor.
Ah.
So mine is already set because I have used the CNC machine here before. Our 5x10 machine here uses this post processor that is UCCNC/UCCNC. You might have to choose it from the library, but it is indeed
Very long.
this one down here. Yeah, there's a lot of post processors. Tormach PathPilot is right up here too. So on the Tormach, this is the Tormach PathPilot. I believe that PathPilot is the one. Tim, do you know if PathPilot is the right one?
Oh, I don't know.
Okay, cool, right on, all right. I'm pretty sure it's PathPilot. We also have a couple of mills that run Mach 3. So, like the Bridgeport at the other building, that's a Mach 3 mill. The 4x8 CNC machine at the other building.
My post location.
What is
Choose another
it? It says
location.
my post location.
Cancel.
Choose another location.
Mine's doing the same.
What'd you click on?
I click on this one.
Select.
And then select.
Yep. And it comes up with this.
I guess choose another location.
Did I choose the wrong one? This one? Two.
It doesn't want it to be in the library, apparently.
Won't let you say select, huh?
Apparently it doesn't like my selection. I don't know.
This freaking thing.
Yeah, none of these are clickable. It's clickable. It doesn't want it to be in the library, apparently.
What is recent? Or if you choose recent up there.
And there's still no options. Nothing. Nothing clickable.
Try closing it and reopening that window. So So there you go. So choose that and you say select.
Yep, same thing. Now,
The post
guess I
process
could-
hold on, let's read that window fully before
Oh,
you close
sorry.
it. The post you are using is from the CNC library, post found here. Receive automatic updates. If you do not want to receive automatic updates, you can, so I guess can you just close that window?
Maybe. Let's see what it did. Yeah, let's click select. Oh no. Let's see. Yeah, so it's not going to let me. If I click select, it comes up with that.
Mine's
If
doing
you
that
don't,
also.
There's just no option to not. Let's see.
I
Copy
clicked both.
selected maybe. Export selected.
what is the little three dots?
Export selected. Let's try that.
And then it comes with this.
Let's select to desktop.
And
Just
say
that's
cancel,
not
I
an
guess.
I think it could be that I downloaded for mine. I downloaded the free version, so maybe that's why.
Well, I have the free version.
You do?
Yeah.
I don't know.
So we'll come back to this. But see, and for me, it lets me say local.
Oh, actually, it is allowing local to be a selectable option for me. It's the only selectable option.
Okay, cool.
But it will allow select folder. There we go.
Okay.
Copy to my posts. Boom.
Okay, cool.
Did it allow for you?
Now
Yes.
it is. Yeah,
All right,
so
cool.
you
So
can
now-
check that out.
Now we just have to give it a name. So a name and number. So this is it's the 15-inch ring. And then I also like to put comments here. The comments that I like to use, the comments will be the first thing when you open up your file and you're looking at it on the CNC machine. You'll see the name of the file at the top of the file, and you'll see a comment at the top of the file. The comments, I like to put notes about decisions I made when I was making this program. So it's a 1/8 inch flat end mill. And I'll write that I went with 60 inch per minute. I'll add in some notes about things that I decided to do there. And that way it's right so later on, if I use this file multiple times, I don't have to remember things, again, because, I'm using my second brain here. Or my external brain, as some people call it. Now I'm outputting it just to my desktop. Wherever you want to save it is fine. And then I go ahead and say post. Done.
Success.
Yeah, it is just that easy. So now that is a file that you'll be able to open up on the CNC machine and push go on. Once you've lined up your 0 with the real world and your digital world, then you're all good.
Somebody literally just asked me about that. How to do that.
Nice.
If I knew how to do it. And I said, no, but you should go to cross class and you will find out.
Yeah. Yeah, we don't do CNC a whole lot in this class. Just because it requires you to get other knowledge from like the people who do the CNC machines, who do the training on the CNC machines. But we'll certainly do it more often if people have that request.
But I just figured you would be way more likely to know than I would.
Right. Cool. So that's it. That brings us to the end. We've generated some G code. We did some other than make a thing that we can 3D print. And we will see you next week.